What's up guys, welcome back to the Timbecon Turning channel and welcome to this, our first ever wood turning challenge series where I am being tasked to create various wood turning projects right here in the wood turning studio. Like any good challenge, the guys have set a couple of ground rules that I have to follow, else I won't pass the final assessment. And for this first challenge, Dane and Colin have told me I need to make a segmented bowl with these following rules. It must be built completely in this room. There is strictly no use of the table saw or bandsaw. The showroom is open for business, so I suppose that means I can go shopping for tools or supplies during the build. And lastly, bonus points will be awarded for using hand tools. At the end of the build, my final piece will be judged by both Colin and Dane with standard turning judgment criteria. So that will be covering the turning itself, the finish, the originality, and finally the difficulty. So that's a challenge. I'm definitely looking forward to it. It will be interesting with the whole no table saw thing. It has put a spanner in the works. But I've definitely faced bigger challenges and I'm confident I can make this work. So it's the next day now and I've had a little bit of time to think about this and I have a rough idea in my head what I can do. The first thing I need to do is machine all of our timber so that we've got two parallel faces and everything's a uniform thickness. That's just going to make my life easier. This little unit here is actually really cool. It's a brand new product for us and it's a benchtop jointer with cast iron tables and fence, and it has a true spiral cutter head. We also have the benchtop thicknesser and that too has a spiral cutter head. So everything that we do here should come out silky smooth and it shouldn't be too loud either. For bringing the edges to be parallel, we're doing something that isn't the best practice, but because of the width to height ratio of this piece, I'm confident in doing so. So we're going to run it through the thicknesser on edge and that should bring our opposite face parallel and we should be left with something that is square on all four sides. Typically the way I would do this in my home workshop is to run it through the table saw, but because of the rules of the challenge means I can't use a table saw, I'm having to think a little bit creatively. Okay, so that is all of the timber machined and honestly I have no idea how much of this I'm going to need, but I'm hoping this is enough. So the next thing I have to figure out is going to be how I cut the wedges. I have a concept in my mind, but I need to put it through the test and try a few things out. And that concept is to use this saw guide, which is for a Japanese saw, and it just holds the saw to be nice and 90 degrees. And also with the fence on the bottom, it will hold it to be 90 degrees to the workpiece as well, so you should get perfectly square cuts. I've had to get a little bit creative with how I'm using the guide, but this here is my solution that anyone should be able to reproduce at home. All it is a piece of plywood with a dressed piece of 19 by 42 scrap glued to the rear edge to act like a fence. On top of that fence, I've grabbed another piece of scrap and this super handy digital protractor and I've glued that on top at exactly 75 degrees to the front edge. Now 75 degrees is what we need for a 12 segment ring, but if you're doing different numbers or other segments, obviously you'll just change that angle to suit you. Now with that set up, it's just a matter of referencing the rear edge of the best saw guide onto that little fence and clamping it firmly in place, and that's it. Our saw guide is set, it's in the perfect angle that we need, and we're ready to start cutting our little segments. To cut the segments, I just set up a stop block to be around what I think looked right for the first spacing, and I got to cutting. Now, Japanese saws cut on the pull stroke, so the saw itself does a pretty good job of keeping the strip firmly indexed against the fence, and all we have to do is kind of press down a little bit. After every cut, we flip the workpiece, clear out any dust, and slide it up to our stop block and cut again. After we've cut 12 segments, we should have a full ring, assuming our maths is correct. And we can test how the ring goes together. And what do you know? We actually are left with a pretty damn good segment with no gaps whatsoever. So take that, table saw guys. Hand tools, winning. Now after each full ring is cut, I just adjust my stop block by a few millimeters and repeat the process to get a larger or smaller ring. I found by adjusting the stop by 2 to 3 millimeters for the narrow strips and 5 millimeters for the thicker strips, it gave me a step over that looked like it should blend together quite well. Honestly though, I have no idea. I'm making this all up as I go, and in the future, I'm definitely going to do some more planning to give me a better idea of what sort of form I'm going for, as I think that would make it a little bit less guesswork and a bit more calculated. Now to glue the rings together, I just used Titebond Original. It's plenty strong and it cures fairly quickly, though its working time is a little bit short, so you need to be speedy with getting it all done. What I found, if I stacked all the wedges together like this and then applied the glue to all the faces at once, it came together really quickly and the glue was still within its open time by the time it was in clamps. Now, if you're struggling to get things together in a timely manner, Titebond 3 may be a better option for you as it has got a longer working time, but there's also Titebond Extend if you are really struggling and want to be safe. For some of the larger diameter rings, I did use large cable ties that I linked together as I just didn't have a large enough hose clamp on hand. This worked pretty well, though the tension I could get on this was definitely nowhere near as much as I could with a hose clamp. So luckily for me, my joints were nice and tight, and this did the job just fine. Now, there was 1 or 2 rings that just didn't close up for some reason. Either I bumped the jig while I was cutting it, or maybe there was some sawdust jammed between the fence and the workpiece. But either way, it threw things off. Now, instead of throwing those rings out, I just glued them up in 2 halves, and I put a nail between the halves as well to keep them separated while we apply the clamping force. The nails will allow the 2 halves to close up perfectly, and once dried, I can flatten the 2 halves individually and glue them back together and get a nice closed ring. There's definitely more steps, but it beats wasting material, and a couple extra steps here and there for tighter rings, I'm happy with that. So we've got a bunch of rings. I've still got a couple to do, but I'll do that off camera. So next, what we have to figure out is how to flatten these rings so we can glue them together and get a nice positive joint. And I think for that, a lot of it's going to be done on the lathe. These thick ones won't be an issue, but the thinner ones, I've still got a little bit of thinking to do on that. This here is a scroll truck that has a set of specialty jaws installed called cold jaws that will allow me to mount a wide range of different diameter rings onto the lathe. By using the cold jaws, I can mount the rings directly onto the lathe and flatten them with a pretty decent speed. For the tool, I used a square carbide rougher, and I just took really light passes, checking a few times with a straight edge to make sure that I wasn't putting a taper on the part. Now, after flattening one side, I flipped the ring and repeated the same process again. Now, the rings came off pretty damn good to begin with, but to make sure they were properly flat, I decided to lap the rings on a flat surface. So I went down to the shop, grabbed some sandpaper and stuck it to my workbench, which is a surface that I know is flat. This step was probably not strictly necessary, but I really didn't want to take any chances with this thing exploding, so a good glue joint is vital. And as you'll see in a moment, there was some low spots that could have potentially caused issues, so yeah, I think it was worth it. Now, when lapping, it's good practice to work the ring in one direction, rotating it every few strokes to ensure you're taking up a uniform amount all over and don't end up with a wedge-shaped ring. To make it easier to keep track of my progress, I added pencil marks onto the faces, and as you can see, these are those low spots I was talking about. I'm glad I did this, but in reality, I do think the glue would have filled those gaps just fine. But hey, I'm a perfectionist, and if it takes an extra 15 minutes, it takes an extra 15 minutes. Now, the thinner rings are a little bit different. They're a bit too thin to safely sit in the cold jaws. I mean, I could use a spacer, but I don't really want to do that. So instead, I attempted to try and do it entirely on the workbench by lapping it. And this worked okay, but towards the end, I can tell you, I was starting to get pretty damn tired. This was essentially the same process as before, but because there was a lot more material to remove, I just used 60 grit paper initially before switching to the 80 grit, which is a step I didn't have to do before. 3 out of 10 is what I'd rate this method. I'll definitely be looking for a better way in the future. Gluing on the blank is pretty self-explanatory. You put some glue on the stack of rings and clamp it together, right? Kind of. One thing about glue is it makes things pretty slippery, and as alignment of these rings is really important for the final product, I decided I'd glue it up in a few stages to give myself the best chance of getting it just right. For the glue, I'm just using Titebond Original once again. It's my go-to, and as it's the most rigid setting flavor of the 3 Titebonds, I think it's a pretty good choice for this application. And for this first glue up, I split the bowl into 3 sections to glue those together individually. Now, I was careful to orient each ring so that they were clocked in a way that each joint would overlap a full segment, and this should result in a running brick sort of pattern in the final piece, and I think it should look pretty damn spiffy. Now, for the clamps, I went down to the shop and stole this display box of spring clamps and ran away before Alex, our customer service guru, had the chance to yell at me for ruining the display. While the first set of rings dried, I remembered I needed a plug on the bottom of the bowl to give me a way to hold it into the chuck. So I turned down a puck, added a tenon, and quickly added that to the bottom stack so that nobody would be none the wiser to my little oversight here. After about 45 minutes, I removed the clamps of the two bottom rings and glued those two layers together, being sure to orient the joints just as before. 45 minutes after that, I did the exact same thing for the last layer and called it a day, allowing it plenty of time to dry properly. And that's left us with this, our blank all glued up, and I think it looks pretty good. Everything looks to be nicely aligned, and I think it should be pretty balanced when we spin it up. So I guess that means there's nothing left to do other than to mount this on the lathe and get turning. There's a few things I've learned getting up to this stage that I think is worth discussing. Now, the first thing that I learned was when cutting the segments, I was just cutting 12 segments of the same size, then increasing the spacing of the stop block and hoping for the best. But there is actually a formula I could have been following to get a more accurate sizing. Now, the formula is really simple. It's the diameter that you want times pi, 3.14 is close enough, divided by the number of segments. That should give you the segment length on the outer edge. Alternatively, there is just a bunch of calculators online that will do this for you, and you can bring it up on your phone and kind of do it on the fly. The second thing I want to mention is the width of the segments. Now, these narrow strips were kind of a waste of time. They were fine for these smaller diameter rings, and they will be put to use eventually. But the thing I didn't consider is as you increase the diameter of the ring, the effective wall thickness that you can get out of the rings gets thinner and thinner, and it essentially makes them useless. Now, the solution to this would just be increase the number of segments of the ring, so say you go from 12 to 18 or 24, but I didn't think about this at the time, and I ended up wasting a bit of time cutting and gluing these smaller pieces to then only later realize that I wasn't going to be able to use them. It's all part of the process and I learnt from it, so still a win in my book. Now, when mounting the bowl to the lathe, I typically use a tailstock to press the bowl firmly into the chuck to ensure that the tenon is fully seated and also give a little bit of extra support when roughing out. This time though, something felt a little bit off as the puck that I thought was jacaranda was just way too soft, and as we'll see a little bit later, that will come back to bite me in the butt. My approach with this bowl was to roughly shape the outside of the bowl to remove all of the step overs or ridges between the layers, and that way I can get a better sense of what wall thickness I'll end up with once it's all smooth, and kind of just get a better idea of what sort of shape I will be able to get out of this blank once it's actually round. I was a little bit nervous to start cutting as I thought when I touched it with the tool it would just immediately kind of explode, but it actually turned really nicely. And it only took a few passes before I was confident to start kind of attacking this thing with some more heavier cuts. For the tool choice, I ended up using a combination of tools, but I started with my 16mm bowl gouge that has a custom grind on it. And I also used my 12mm bowl gouge for some parts of it, as this has a 40/40 grind and it just is a little bit easier to use in some places. These gave me a really nice finish, and as long as I was performing a push cut like this, the surface finish was coming out really nicely. There was some fuzziness, but that's to be expected with the softer timbers that I used in this blank. Once I had the outside roughly shaped in, there was one layer towards the top of the bowl that was feeling pretty thin, so before doing any more work on the outside, I thought I should do the same thing on the inside, just rounding it out and smoothing off the steps between layers. On a standard bowl, I would usually use my bowl gouge to do all of the hollowing, so that's what I did here, and it worked really well, but once I got a little bit deeper into the bowl, it almost immediately catched and was ripped from the lathe. This is where that really soft wood came back to bite me. The moment there was a hint of a catch, it was just sheared right off that tenon and the blank went flying. Luckily, it was a clean break that could make a good glue joint, so I just glued the two bits back together, let it dry overnight, and picked up from where I left off. Seeing how easily this thing broke, I decided to change over from my bowl gouge to my probe hollowing tool from Crown, as this would give me a really decent amount of control and allow me to take super light cuts when hollowing. Now, it is a carbide tool, but because the cutter is dished out and has more of a traditional cutting edge, you control it like a traditional tool and not necessarily like a scraper as the more common easy wood tools get used. As you can see, you don't need to worry about keeping it on center, nor does it need to be flat on the tool rest. And once you get the angle just right, it's super easy to get those precise whisper thin shavings right off the tool. Just as I was working down to remove the last of the ridges, I flattened out the tool to get a slightly more aggressive cut, and yeah, the exact same thing happened again. And it wasn't on the glue joint, which I found quite surprising because I thought if anything was going to fail, it would be that. So it goes to show, glue is actually pretty damn strong. After that, I decided that was enough and I made a new tenon from a much harder wood and just replaced the entire puck. The way I did this was I just reverse mounted the bowl in some cold jaws, cut off the pine layer with my Japanese saw, and then flattened the bottom. Then, using a second scroll chuck on a threaded live center, I used the lathe itself to glue the new tenon in place with perfect alignment. It's a really cool method for doing this sort of thing, and because we were already pretty close to its final shape, I didn't want to take any chances with gluing that puck on off center, so I had to just show off a little bit and use multiple chucks and be that guy. Look, I'm sorry. I usually try and only use one chuck at a time, but sometimes you gotta use more than one. With all of the inner ridges finally taken out, I was only left with about 5mm or so worth of wall thickness in the bowl, so unfortunately, there wasn't much else I could do with the form. The shape would make a really nice lampshade, but as a bowl, it wasn't great. It's not bad, but not great. But hey, the joints are tight, nothing exploded despite being thrown off the lathe twice, and things were still looking fine. To finish things off, I scraped the outside of the bowl smooth and then turned my attention back to the inside to just get things just right. About halfway down the bowl, there was a slight bump, and I really wanted to get that taken out because I knew the guys were going to be judging this and they weren't going to go easy on me. So with my bowl gouge, I super gently chased that out bit by bit until I was left with what felt like a nice, smooth internal wall shape with no bumps or ridges, and called it good. Now I think I got a little bit carried away when doing this because I ended up getting a much thinner wall than planned. So next time I'm going to remember to check my progress more often so I don't end up with a 0.7mm wall thickness. I sanded my way through all of the grits from 80 to 320, and for the finish I used two products. The first was the U-Butte Finishes Triple E Cut and Polish. This isn't actually a finish as such, but more of a pre-finishing stage to bring it from a sanded surface to a bit more of a polished surface. Goes on just the same as most other lathe finishes. Put some on a rag, apply a light pressure and buff it in, but it's technically not a finish. After the Triple E was applied, I then followed it up with 3 coats of Shellac Wax finish from the same company. This is a friction polish, so it's very similar to the Triple E, but it has a fair bit of shellac in it. So unlike Triple E, this will actually seal in the wood and protect it for a long time and kind of act as a barrier. With that, the bowl was finished, and all I had to do was part it off the lathe, remove the stub that was left, and call it a day. And there we go, the bowl is turned, and it's not bad for the first segmented project I've ever done. The shape is a little bit average, but as far as the process goes, it's been very enjoyable, and I'll definitely be doing this again in the future. So I guess that means it's time to take it over to the 2 blokes that actually gave me this challenge and get this thing judged and see if I get a passing grade. I think I will, but let's see what they have to say. Now, you may not recognize their faces, but these 2 guys have actually been on the channel several times with various projects, and they're kind of the guys I usually go to for all my questions when it comes to wood turning. So they're going to be judging my pieces. This is Colin, that's Dane. Let's see what they have to say. So just to remind everyone of the rules of this challenge in case you forgot, the bowl had to be built entirely in this studio. I was not allowed the use of any table saws or band saws throughout the duration of the build. The shop was open for supplies and extra tools if I needed them. And there was also bonus points for using hand tools, and that is the main reason we went the hand cut method. So let's hear what the guys have to say.
Overall, joins are pretty good. It's like no gaps, especially for the first attempt. Finish is really good. Turning could be improved on the inside, but for a first attempt at segmented turning, it's actually fairly good.
Yeah, overall, I think it's come out pretty well. It was pretty hard to start with because it was literally a bunch of random rings to try and put together into something that resembled, a bowl or a vase or something. So with no pre-planning, it's come out pretty well in the end. Finish is very good, and the overall shape is pretty nice. You worked with what you had. It's like turning with normal wood. So, but yeah, I mean, for the first attempt, yeah, you can't really complain with that.
And especially being hand cut.
You didn't throw it off the lathe, so, and it is quite thin.
Well, I did throw it off the lathe twice, but it didn't explode.
Yeah, so it is almost see-through on some spots. So, but yeah, just that inside could have been a little bit better. But there's always something you'll pick on the projects that you'll do better next time. So
yeah. Well, I was aiming for what the rim thickness is, and chasing out that hump in the inside that you picked up is why it got so thin. So I had to give up when I started seeing line.
Yeah, good effort. And next time I want to see a 48-piece one.
Yeah, maybe. Alright, so I passed?
Yeah.
We should have discussed this ahead of time, but next challenge.
We'll go to the speed challenge. You do your hand cut, I'll use the table saw.
And I'll design the form.
Yeah, so we have to meet the form that you come up with.
Yep.
Perfect. All right, well, there it is. We have a finished bowl. Judgment went well. They picked up on a few little things in there, like the hump that I was trying to get rid of. But you know, that was to be expected. So all in all, pretty happy with that result, and the guys have actually given me the thumbs up. So the next challenge is going to be another segmented challenge, but it is a speed run. It is me versus Colin, and we have to come up with the same form, but one method using hand tools and one method using the table saw. And I am the sucker that has to do it by hand again. So stick around if you want to see that one. Colin is the master of all things segment, so I doubt I'm going to win that round, but it'll be a good challenge and I think it'll be a lot of fun. If you've enjoyed this kind of challenge, make sure you leave a comment below. I've had a lot of fun doing it and I think it will make for some good projects in the future. Thanks for watching, see you next time. Links to everything is in the description like always, and if you haven't already, head over to timbecon.com.au and check out all of the things we have on offer. We do a lot more than just wood turning stuff, but being a wood turning channel, that's what we're all about here. All right guys, see you next time.